Today we're going to look at another type of series and look at its convergence and divergence, and that is an alternating series. Up until now, every series that we have had, one of the things that had to be true is that every term of the series had to be positive, right? We couldn't have any negative terms at all. Now, in you know in the bigger picture, if all the terms of a series are if all the terms are negative, you just factor a negative out and determine whether the positive term series converges or diverges, and that'll tell you whether the negative term series converges or diverges. Um, but more interesting to us is one like this, an alternating series where the terms go positive, negative, or they can start negative, negative, positive, etc. And actually, this is one of the easiest to determine whether the series converges or not. So if you have a sub n is greater than 0, so the non-alternating part must always be positive, right? You don't want it to be, sometimes goes negative, negative, positive, or positive, positive, negative, or something like that. So a sub n has got to be positive. Then these two alternating series, this one starts negative and then changes to positive. This one starts off positive and then changes to negative, is going to converge if you only need two things. The first thing is that the limit as n goes to infinity of a sub n has got to be equal to 0. Well, that's just the nth term test, right? That must be true. And each term must be less than or equal to the previous term. As long as those two things are true, then the series is going to converge. So alternating series, unless they're really horrible, they tend to converge. Okay? So here I've showed a diagram where if we start at 0, if this is the first term, a sub 1, then in the sequence of partial sums, remember we did that at the very beginning, S1 would be A1, right? And then if this is A2, notice I didn't go as far to the left because each term's got to be less than the previous term. So this would be S sub 2, the second sum of the sequence of partial sums. And then from there, we'll go this way, but we can't go all the way to here because this has to be smaller. So we're going to go to there. This is going to be S sub 3. And then it's just going to keep bouncing back and forth, but each time, I should have marked that was a sub 3. And from there, we're going to go this way, but we're going to go less than we went before. For a sub 4, so that's going to be S sub 4. So you can see what's happening. It's a damping oscillation. Just like if you start a pendulum, eventually it starts slowing down to where it stops unless you have some force that's acting on it. Just the wind resistance do that. Or the same thing with a spring. You set a spring in motion, it'll go up and down and up and down and up and down, but it keeps getting less and less each time. That's basically what's happening here is we have this damped oscillation, and eventually it's going to stop somewhere. Now, where is it going to stop? Okay, we don't know that, but we know that it's going to be somewhere in here, right? And each time we add on another term, we make that little window that the sum can exist in smaller each time, right? So this is just the note that if this first part doesn't happen, it fails the nth term test for divergence and it diverges. All right, so let's take a look Let's determine the convergence or divergence of each of these series. So we just need to, it's an alternating series. You should always state what type of series you're dealing with. The limit as n goes to infinity of 1 over n is equal to 0. That's the first thing we have to check. And 1 over the next term is n plus 1. That's always going to be less than 1 over n. So that checks. Therefore, this series converges. The question of to what does it converge is a little bit more difficult. And it's not something that we'll do in this class, frankly. We will talk a little bit about convergence. I don't know if it's tomorrow or later this week, but for series like this, because something really interesting happens, but we'll leave that. All right, page 2. So if we look at this one, if we take the limit as n goes to infinity of the non-alternating part, n plus 1 over n, that's equal to 1, which because it's not equal to 0, we know that this series diverges. By the nth term test. Because if we did the nth term test on the whole, how should I put it, on the whole term, including the negative part, what it would do is bounce back and forth between -1 and +1 as n went to infinity. The terms aren't getting close to 0, so there's no way that the series can converge. It's absolutely going to diverge. All right. So although we don't know exactly what these will converge to, we do have something called the alternating series remainder theorem, which says that if a series converges by the alternating series test, then the absolute value of the remainder, r sub n, and you can think about the remainder as being the error involved in approximating the sum s by s sub n, is less than or equal to the first unused term. So the error, which is the difference in the sum of the whole series and the nth partial sum, has an absolute value that's equal to, we call that r sub n, the remainder, or the error, same thing. That's less than or equal to just the positive part here, a sub n plus 1. Now, why is that true? Let's go back up to this diagram. So right now, I know that if I summed the first 4 terms, so I said, I think that's the sum of the series. The worst off that you could be would be the next term, a sub 5, wouldn't it? That's the furthest you could be off. Now, your book, I think a little bit stupidly, frankly, doesn't pay attention to the signs of these, but the sign will also help you give an interval. For example, if you summed the first 4 terms, then we know that the actual sum will be somewhere between s sub 4 and s sub 5, right? What they do is when they ask for an interval, they take s sub 4 and they add and subtract a sub 5. I'm like, okay, why bother giving anything over here? We know it's not going to be less than this if the next term is positive. If we were summing after the third, it would be somewhere between here and s sub 3 minus a sub 4, right? Because it's going to be to the left. So when your book gives answers, it sometimes asks for a range of values. I'm like, why? Why do you add and subtract the next term? You should just look at the sign of the next term and decide whether to add or subtract that next term from the sum of the first however many terms you've done. To me, that makes a lot more sense. So here, let's approximate the sum by its first 6 terms. And I'm going to add on one little piece and give an error bound. All right, so this starts off positive. So the first 6 terms are 1 over 1 factorial minus 1 over 2 factorial plus 1 over 3 factorial minus 1 over 4 factorial plus 1 over 5 factorial minus 1 over 6 factorial. So let's see. That's 1 plus a half plus 1/6 plus 1/24 plus 1 over 120 plus 1 over 720. And I'm sorry, I forgot to put the negatives in. Minus here, minus here, minus here. I have no idea how much that is. Unlikely that that's something that you would be asked to do by hand. So 1 minus 0.5 plus 1/6 minus 1/24. Oh. Hate it when I forget to move out of. So plus 1/6 minus 1/24 plus 1/120 minus 1/720. And that's 0.632 about. With error, where the absolute value of the error is going to be less than or equal to the absolute value of the next term, which is 1 over 7 factorial. Which is incredibly small. 1.984 times 10 to the negative 4th. Generally, with alternating series, you can get very good accuracy pretty quickly. Even here, where the terms, here especially, the terms get small really quickly because the denominator gets really big really quickly. If you had, like this one, where it's 1 over n, it takes a little longer because the denominator doesn't get big nearly as quickly. Okay? All right, one other one. Determine the number of terms required to approximate the sum of the summation as n goes from 0 to infinity of negative 1 to the nth over 2 to the nth times n factorial, which is equal to 1 over the square root of e. Like, okay. And we want to have an error less than 0.001. So the absolute value of R sub n is going to be less than or equal to A sub n, and we want that to be less than or equal to 0.001. We want it to be less than 1/1000th. So all we have to do is figure out, and I'm sorry, that should be A sub n plus 1, shouldn't it? Yep. So we need to figure out, well, what is the first term, not including the alternating part, where this is less than 1/1000th? And we can use a calculator for this. The simplest way, I think, is just to load that into y sub 1. And we're going to have 1 over 2 to the nth times n factorial. For factorials, I usually go to the math menu and to probability, and it's there. There's probably other places to get to it, but that's where I do it. And then what I'm going to do is I'm going to set up a table where I'm going to start at 1 and increment it by 1, and I'm going to let it automatically do it. Table's over here. I always think table set and table ought to be together. They're not, for reasons that I don't understand, but let's see. So that's 2 100ths, almost 3. So that's 2.6 times 10 to the negative 4th. So we'll have moved the decimal 4 places to the right, so the 2 will be in the 4th decimal place. So that one's smaller. So that means A sub n plus 1 is 5. Or n plus 1 is 5. So A sub 5 is equal to, what was it, 2 point something. 2.6 times 10 to the negative 4. Which is less than 0.001. So we need 4 terms. And let's just check this just for grins. So the sum of the first 4 terms, the first term is going to be 1. I've got negative 1 to the 0, which is 1. I'm sorry, it's going to be 1/2. 2 to the 1 is 2. I'm sorry, 2 to the 0, it's 1. I apologize. I was right to start with. 2 to the 0 is 1, and 0 factorial by definition is 1. I know it feels like it ought to be 0, but it's not. So that's 1 minus, At 1, that's going to be negative. That's going to be a half plus, this will be 1 over 2. So that's going to be 4 times 2 is 1/8 minus 1 over, this is going to be 3, so that'll be 8 times 6 is 48. Let's see what that comes out to be. 1 minus 1/2 plus 1/8 minus 1 over 48 is 0.60417 approximately. And 1 over the square root of e is 0.60, oh, well, I'm not happy about this, 6065. That looks to me like that's a bigger difference. Oh, that's n equals 5. So since we started at 0, we actually need 6 terms. Or we need 5 terms, excuse me. So if we add on the next one, which would be 1 over, let's see, that's the 4th, so it's 16 times 24. There we go. So we actually need 5 terms. We need through n equals 4, and it started at n is equal to 0. Sorry, that threw me off. This comes out to be 0.6068. And you can see now that that's less than 1/1000th off. It may be the easiest way to do that, rather than to do this, if it's not very many terms, is just start listing terms until you get to one that's less than this, and then go, you have plus, whatever. You have plus 0.00012, and you're like, okay, and I'm going to cut it off before that. You see what I'm saying? If it's a lot, then absolutely don't do it that way. All right.